Okay, so we're going to be talking about electron configuration. On this first slide, you know that electron configuration is the arrangement of electrons in an atom. Ground state electron configuration means that the electrons are at the lowest energy arrangement. There are three basic rules that we need to know about electron configuration. The first one is the Aufbau principle, and this one says that an electron occupies the lowest energy orbital that can receive it. You have to imagine that these electrons are very, very lazy. They do not want to move away from the nucleus, okay? So they always want to stay at the lowest energy level. Now, the lowest energy level is the 1s, and that's right here on the bottom, okay? That is your lowest energy level. Or we can also think of it as the electrons wanting to stay as close to home as possible. So if you notice right here in this chart, this whole entire chart right here, it actually shows you the different energy levels. We have the 1s right here, then we go up to the 2s. Next would be your 2p, 3s, 3p, 4s, but if you notice right here, we have the 3d in between the 4s and the 4p. 4s has the lower energy level than the 3d. So when we're writing these, we have to keep that in mind. The Aufbau principle continues saying, beginning with the third energy level, of the sublevel, and different main energy levels begin to overlap. And that's what we were just talking about, how the 3D was in between the 4S and the 4P. Now, another way of looking at the Aufbau principle is by actually taking into account the Bohr model. Now, the only thing is that we've always known the Bohr model as seeing little circles, but within that circle, around that nucleus, if you notice here, on the 1s, there's nothing other than the 1s. But on the second energy level, we have the 2s and the 2p. So we have, I guess you can say, different communities within each energy level. Now, the Pauli exclusion principle says that no two electrons in the same atoms can have the same set of quantum numbers. The two values of the spin quantum numbers allow two electrons of opposite spins to occupy the orbital. So, like we were talking before, each and every one of these two electrons will have an address. And we'll talk more about the address later, which is the quantum numbers. But they both have, there's only two that can actually have the same address. Now, if you notice here, we have hydrogen right here with its one electron. But when we get over here to helium, you notice that the arrows, which are representing the electrons, are actually facing in opposite directions. Now, think about it. Electrons have the same exact charge. So if they were going in the same exact rotation, in the same exact direction, then they would actually repulse one another. Now, since they are in opposite directions, they're, I guess you can say, better content with one another. They're able to just withstand one another, and so that's the reason that you can have two within each of these little compartments. Now, like they say, three's a crowd, so no more than two. That's very important for you to remember. No more than two. Hund's rule. Hund's rule is the second rule that we have to take into consideration. It says orbitals of equal energy are each occupied by one electron before any orbital is occupied by a second electron, and all electrons in singly occupied orbitals must have the same spin. So, if you notice down here, I actually gave you an incorrect one and a correct one. You have to think of it this way. You can go from the 1s, and once it's full, you go up to the next energy level. The next energy level, you're going to start off with the 2s. Once the 2s is full, then you go on to the 2p. Now, later on, I will show you how to actually use the periodic table and make it a lot easier than having to memorize 1s, 2s, 2p, and keep on going from there. Like in Hund's rule, it says that each of these electrons like to have their own room. They really don't want to partner in this. They really, really have to. And in order to go on to the next energy level, you have to have 2 per, and I call them rooms. Okay? These are kind of like apartments. So you have to have 2 per room or per apartment before you keep on going to the next energy level. So in this one right over here, it is incorrect due to the fact that we have these two that really don't have to be living together or be with one another, and they can have their own space. See, you have these 2 empty rooms here, so that's why this would be the correct answer. Now let's take a closer look at electrons and where they are in the atom. Electrons are located within energy levels which range from 1 to 7. The higher energy the electron is in, the further away from the electron is from the nucleus. The further away the electron is from the nucleus. Very important for you to remember. The more energy the electron has. So the higher the energy level that the electron is in, the further away it is from the nucleus, and then the more energy the electron has. That's kind of weird in the sense if you're thinking about it, but I want you to also think that the electrons are kind of like you guys when you go off to college. Now, we know that you behave when you're around mom and dad. Well, the electrons do too. And once they're far away from mom and dad, they start doing things that they might have not done before. So in this case, the electrons start gaining a whole bunch of energy. Now, the energy levels are actually located right here on the left side of the periodic table, and they're known as your periods. Okay, so your period numbers, and I have wrote it right here, your period numbers are actually your energy levels. Now, on this sublevels, we have what are known as your orbitals. Okay, so the sublevels in each energy level differ from each other by slightly differences in energy. Orbitals are the paths in which each sublevel that an electron can actually travel, or that we imagine in them traveling. So each orbital can hold a maximum of 2 electrons. In every s sublevel, there is one orbital which holds a total of 2 electrons. In every p sublevel, there are 3 orbitals which hold a total of 6 electrons. And then in every d sublevel, there are 5 orbitals which can hold a total of 10 electrons. In every f sublevel, there are 7 orbitals which can hold a total of 14. Now, in what order do they actually fill? So, if you look at this, you actually have 1 through 7 right here written. And then the next one starts 2 through 7, 3 through 6, and then 4 to 5. And then you just put S all the way down, P, D, F. In actuality, you don't even have to memorize that because the periodic table is actually telling you how to do that. Now, writing the electron configuration for an atom is quite simple. The first thing is the format for the electron configuration is, for example, if I write it as 1s2, The 1 stands for the energy level, so the number on the left side of the periodic table. The S stands for the sublevel or the orbital, and I usually tend to think of SPDF as different houses, types of houses. So we'll start seeing what they look like in the next video. And then the 2 actually tells you how many occupants, or the number of electrons that are in that sublevel. Now, what is the significance of electron configurations? Electron configuration actually tends to show you a little bit more about the valence shell, the outermost energy level of an atom. Valence electrons, electrons in valence outer shell, are important because those are the ones we're going to be using for bonding. So that's why I had you actually watch the video about the valence electrons. It's really important that you know how many they have and how they're, because that's going to explain how they're actually going to be bonding. What is the maximum number of valence electrons an atom can have? Is 8. And again, like I said before, it is called or known as the octet rule. How many do each of the noble gases differ? How do each of the noble gases, differ from other atoms? They all have full valence outer electron shells. Now, all of them have 8 valence electrons except for helium that has only 2. And the reason that helium has only 2 because it only has 1 energy level. Okay, so again, on the first energy level, you only have 1 type of house or 1 S. Okay, it's only when you start moving further down or further into the other energy levels that you start having different types of subshells or orbitals. Now, how do noble gases behave? They're not very reactive. Once an atom has a full outer shell, it will not attempt to gain or lose any more electrons. But the funny thing is if you remember the when we're looking at the gas tubes that I was actually showing in class, each one had its own little bright light. Okay, so do they get aggravated if you shock them? Yeah, of course. Anybody would get aggravated. And also, kind of like what we did with the flame lab. If you were to introduce a little bit of heat or fire, they're going to soak up the energy from that heat and become more hyper. And again, they're going to react, but not very much reactive, okay? All right, until the next one. Thank you.